Hello everyone, welcome back to my channel. Today I'm going to demonstrate to you how you can set up your Prosoft card from the time you download the software, the AOP software, including the configuration builder, all the way until how you program it on your Studio 5000. Let's get started. First, of course, you need to download your Prosoft configuration builder. You can get it from ProsoftTechnologies.com. Go in there, and then if you roll your cursor over the products, you go Prosoft software, and if you scroll this thing down, you can see Prosoft configuration builder here, available here. And if you scroll down, Prosoft software and configuration builder is here. I do have a demonstration of how to install this step by step. I'll put a link on the top right hand corner of this video. If you like, please check it out. But once you download the software, you should have Prosoft configuration builder here. Another way to find is you go download for Prosoft technology, and then right here, Prosoft builder. That's what it comes up with. So the version I have at the time of recording is 4.5 is what I have, and that's what I'll be using. So I'm gonna minimize this for now. Another piece of software that you'll need is you go product, Rockwell automation in chassis. So the Prosoft card that I'll be using is on a compact Logix, and its model number is MVI69E MBTCP, right? This guy right here. So I click here, okay, and you click on download. So over here you can find the EDS file, including the AOP file itself. So the difference between EDS and AOP is that EDS file will facilitate identifying the hardware. Say for example, if you have RS links. So if you don't have the proper EDS file, you'll be plagued with this yellow question mark and X and unrecognized device, and all this comes up. With the EDS file, it helps you identify the device and what have you. You know, you can actually see it, but you can't really identify a device. Like if you have a proper EDS file, you will identify a device like that with a nice little icon. Well, EDS will help you do that. But what AOP does is that, and also on top of that, it helps set up the hardware correctly. If you're using Studio 5000, I recommend you to use AOP. So I'm going to close this guy here. I recommend you use AOP instead of EDS. So AOP is pretty straightforward. You click this guy here, and then you get this file here. If you unzip this file here, extract all here, you have to run the MP setup. But make sure that you have closed all your studio, including your RS links, before you start installing, or else you will not be able to install. Another way you can actually get all those appropriate files will be to download the EDS file. So once you download the EDS file here, let me try it here. It's not that bad. So once you download the EDS file, this is your EDS file. You extract it here on the same location. So you have this EDS file. The way to install the EDS file, you go start here and type EDS. EDS hardware installation. This is a software that comes together with any Rockwell when you install Studio. So you say add, register directory in EDS, look for subfolder, and you browse. So this is on the download folder. So you go download EDS, oops, not this one, this guy here. You say OK, and what it'll do is that when you go through it, you'll find all the EDS file, and once you click it, it will install the EDS file and whatnot. So I already got the AOP and EDS file, AOP installed on mine because I'm going to use Studio. So I'm going to close all these things here. So you have downloaded, now you should have downloaded your configuration, Prosoft configuration builder, and your AOP file or your EDS file. Now you're ready to actually install or introduce the card to your program. So I'm gonna close this guy here. So I'm gonna start Studio 5000 and create a new project. It's gonna be called Skynet, And since our card is for compact logic, so we have to put a compact logic CPU, say L36E RM, and just going to put it on a desktop here. Doesn't matter which version I have, so no protection, finish. So I'm going to expand this and maximize it. So we will introduce your MVI69E MBTCP card here, right here on the 769 bus. Right click, new module, and over here just remove all the check and just put check on Prosoft Technologies. And if you remember, my card that I want to install will be MVI69E MBTCP. So this is the module that we want. There's a couple of other ones called L, just be wary which ones you want, right? So before you create, let's open our controller tags. Just hold on, let's go back here. Open your controller tags. What I want to show you here is that when you add a card here, you can actually see that it creates a couple of tags here for you there. MVI69E MBTCP, hit create, and you give it a name. This name is just for the name that appears on the card itself. Right, it's going to be in slot there. You got tons of slot there, so you're going to put in slot 1 there. You can change all the keying and whatnot if you like, even the word sizing. Normally I don't monkey with this, I just leave it as default. So once you hit OK, notice how the input-output channel comes in here. This will be handy when we introduce the Addon instruction here, but we'll get back to that here. So now you have added your Prosoft card. So I'm going to minimize this guy here. The next thing you want to do is to program your Prosoft. Okay, this is your Prosoft. I'm going to expand it here. So File, New. There's a couple of other Prosoft card that's available here, but the one that we're after is MVI69E and MBTCP. If you click this, you'll set up all your clients for you. So you click OK. Okay, so over here, this one you can just rename whatever you want, including this guy here. You can rename the location whichever way you want. Right, so you expand here, go module. So I want to bring your attention to the module. You right click this guy, you hit configure. So this one here allows you to configure the number of internal registers. So what we have here by default is 0 to 600, so which means 0 count is 600. 0 to 599 is meant for read registers, right? And for write registers, it starts from 1000 going all the way to 1599, right? So those are the ranges it covers. So what we'll do today is, this is my Modbus map, which I always use for this intents and purpose. I got a total of 600 registers. If I scroll all the way down, you can see 599 is my last registry, right? And then this is for read. Just let's focus on this first to keep things simple. On the right, it starts at 600, and then it goes all the way down. It's got how many? 600 registers. So it goes all the way down to 1199, all the way down 1199. So we can set up that way. So 0 to 600, right? Oops, 0 to 600. Let me park this one here. 0 to 600, because I got 600 registers. And then on the right, we start at 600 because the read registers ends at the 5. So the start is 600, and we have a total of 600 registers on top of that, like that, right? So and the failure flag, we leave it as it is, and everything else the same. So basically what we've done is that we've created 600 read registers and another 600 for write registers. I'll demonstrate how to use this spreadsheet as I move along. You can document any way you want, but I do it this way here. So once that's done, hit OK. The next thing we're going to do is server here. By the way, we don't have anything for server. Just going to skip this guy here. The next thing we're going to do is client. So we're going to connect to the Modbus slave. So if you right click this guy here, configure, So this is where the spreadsheet comes into play for me, I guess. What I do with this is that when the client tells me that they've got certain registers, I mapped it according to this, like that. So for command number 1, function code 3, I start with that. So let me show you what I mean by that. So add row, if you do edit, make sure it's continuous. Internal address, we start at 0, right? And then pull interval 0. Number of registers we want to pull would be how many? 20. And then no swapping of bits, right? There's a few different swapping. I'll leave the detailed explanation of what this one does on the comment section. IP address would be the IP address of the slave, not the Prosoft, right? Let's say call it 11. Port number for Modbus TCP. Slave address, it could be anything from 1 to 255. And I'll be reading a holding register, right? Holding register 40,000 registers, and it starts with 40,001. So Modbus, the Prosoft starts, is a 0 base, so this is 0 is 40,001. So this is your slave Modbus address, which means when you say 0 here, it means 40,001. So with 20, it goes 40,001, 2, 3, 4, all the way down here to 20. So hit OK, that's done. And the second read I have is for function code 2, which is your bit, right? So I'm going to add a row here, edit, continuous, make sure it's continuous, internal register. Okay, so this is a bit. The internal registers, this one is only for integers. For coil, every integer is a word, it's a 16-bit. That's why it jumps from 16, 32, you know, all that. So if I want to start with my internal register of 25, this one has to be 400, which means that's 16 running numbers all the way to 400 for 25. So internal register is 400. Okay, and then pull. Number of registers I'm pulling would be 49. Say 49. 49 plus 16 is 55, I think, if my math is correct, because 49 plus 16, 65, I'm sorry. 65 registers, no change. IP address is 192.168.2. Say it's from the same address, right? Same Modbus client address, port number, slave address, and this is going to be for coil. Function code 2, Modbus address. If we put 0 here, what it means is that it means 10,001, right? It's a 0 base, and hit OK. So now we're going to do the write. So you go edit row, double click this guy here. So we're going to try to read 40,000 register. So continuous, internal address, it starts at 600. And then pulling interval 0, count, how many do we have? We have 8. 8, no change. IP address is the IP address of your slave. Say it's the same slave. Port number 502, slave address 1. So now we are reading, we are writing to a holding register. So we're going to have to say this is function code 16, right? 16 preset. And then this one here, we're trying to write to 40,801. So since it's a 0 base, you're going to have to write 800. Hit OK. And then if you want to write to a coil, output to a coil, just going to try writing here, add row, edit, continuous, internal register. Again, this is a coil, so you're going to have to look at this. Again, they are 16, right? You can see they're jumping 16-bit. And internal register 602 would be 9920. 9920, and then register counts would be 9951. Oh, sorry, it's going to be 31. Sure, 31. And the IP address would be 192.168.2. Say from the same Modbus slave. Port number 502, slave 1. And over here, we're reading a function code 15, which is a coil, right? Multiple coil. And the address that we're trying to write to is 0001. So 1, this is 1, so it's a 0 base. We're going to leave this as 0. Okay. So we can add more clients and other clients if needed to be, right? Just for demonstration, we can do this. But we're going to have to search for an empty slot here. So say, for example, what I do normally is I highlight here, say I want to read this much, and I allocate a slot for client number 2, right? Copy, and I put it here, say for example, paste, and then this is going to be client number 1, and this is number of register count that you have. Command 1, function code 3, say this one you're reading 100. Something like that, and I'll show you how to do that on Prosoft. Again, this is my way of documenting. I think documentation is good to have. We are reading internal register is 33, right? And then we are reading 6 of them. And then this has no change. So this one says from another controller, say 88. Port number that, and maybe a slave address of different kinds, say 22. And you're reading holding register 40,101. So over here, you gotta have to write 100 because it's a 0 base, right? So I'm just gonna leave it like that for now, right? So you can see all the configuration here at a very high level. One thing I want to underscore is this. So client 0, there's 4 commands that's going on, 1, 2, 3, 4 of them. You can actually put diagnostic to it. So the way to do it is if you right click here and configure, and then you find a spot somewhere. Normally I try to group them together into one. I'm just going to clean this guy here. Say 30, right? So if you say 30, if you put here 30, oops, no, we can't do 30. You got to find 5 consecutive row after 30. So I'm just randomly going to choose something, right? Say, for example, 100. So if you put 100 here as an internal register of 100, what it does is that 100 here, so 1, 2, 3, 4. So this 4 internal registers will be reserved for diagnostic purposes. So for example, if there's the cable is disconnected from the Prosoft, if you look at the controller tags on the Prosoft, this will show -48 like that. -48. That will be the value on that controller. So that indicates that you have issues with your COM. So these are codes that which I think I'll put it into my comment section here if I can find it. But normally it should all show 0 in there. So if you put 100, you'll start to use 100 internal register for diagnostic purpose. Try it out, see how it goes, right? So I'm just going to clean this up. So if you're not using it, it's only for diagnostic, just put -1 and that will do it. Okay, so that's your Prosoft configuration. Now, the next thing I'll do would be to add your add-on instructions. The program will actually allow you to create an add-on instruction. So if you right click this guy here, you can see export AOI file. If you click this guy, it'll create an export file for you. Just going to leave it on my desktop here for now. So it's basically a rung that you put in place. So you open your program here, and you go to your task. Could be anywhere, right? You can even spawn a new routine if needed to be, right? And this is going to have to be a letter because they will give you a rung. So if you open this guy here, I'm just going to erase this, we don't need it. So right click here, import rung. So before we do that, let me open up the controller tags again. So what it does is that since we said that over here, or if we open the Prosoft here, since I said that the Prosoft module configuration, it has a size of 0 to 600, this will be the size of my array, 600 for read register, and write register, there'll be 600 array size too. Let me show you what I mean by that. I'm going to close this guy here, minimize. I just want to demonstrate to you that the tags will be created on the fly, so you don't have to create a tag manually. Import rung. So you select the L5K file that you just created using the Prosoft, this guy here on my desktop. You open it. There you go, it created 2 tags for you there. Another thing I want to underscore is that it did complain that there's a collision in name. This is because when you added the MVI69E hardware, these 2 tags, if you remember, was automatically created. So when they create this tag here, they're using that one here. When they try to create it, they say that those tags exist. But nevertheless, right, this Addon instruction created these 2 variables for you there. So I'm going to close this guy here. If you expand this guy here in the data, so there's 2 sections here, read and write. So you can see that 600 a piece, right? So in future, if you decide to resize it to say this one, you're going to go from 0 to 1,000. If you decide to put it to 1,000 registers, and this one obviously can't start with 600 anymore because there'll be collision. So say it starts at 2,000 and goes all the way to, say, I don't know, 1,000 as well. And when you do that, when you hit OK, make sure that on your program itself here, make sure that you go to your user define here. Make sure you increase your array size in here as well to 1,000 each, right? If you ever make that changes. So for now, I'm just going to leave it at 600 here and push this back to 600 as well. This was 600 and this was starting at 600, and we're reading 600 registers all in total. So once that is done, so this is where all your data will be populated. After this, you're on a home stretch. So what you have to do is, of course, go to communication, who active, and then you download this program to your ControlLogix. And then on the Prosoft side of things, there's 2 ways to download. One way, you have to, of course, select this one first. So this is how you write to your controller. Another way to write would be download from PC to device. When you click on it, they give you an option window to do RS-Who and all that, right? You can this will open RS links kind of look alike, and select your PLC, not the Prosoft card, and then you test connection and you download. Download means write to the device. So once that is done, go online with a controller. I'm sorry, I don't have a controller online with me today. Go in here, so you can see that it has an array 0, 1, 2, 3, 4, 5. I want to take a bit of time to explain how this array thing works. This is my mapping. I've used this for different purpose and different project in my past life. So let me bring back the Prosoft here. I'm gonna park this one side here, and the Prosoft, gonna park it on the side here. As you know, the clients, line number 1, the way I programmed it is for this guy here, command number 1. So if you need to see what's the content of 40,001, you would read 0. That's my index 0, right? Array index 0, and so on. So if you want to see the content of 40,020, you would look at 19 here, right here, and so on, right? So and then if you want to look at the coil, you look at number 25. and you have to do bit stripping for that too, right? So let me do one more thing here just to finish off here. So add a routine. What I'm going to do is I'm going to read this MBTCP data, read data, and map it into the control logics controller tag here. So I'm going to call it Prosoft mapping, and then I don't know, maybe he will hate me, but I'm going to use structured text. I've always used structured text because it's pretty rudimentary and straightforward, and it's repetitive. When I put it that way, I'm going to expand this guy here for now. Okay, so like for example, copy, right? And then I'm gonna go here. So let's say the 40,001, these two are floating point, right? So I have to read them together. So on my structured text, I'll go comma, and then you have to create a tag. I don't know, 1, 2, 3. They say it's a pressure 2, 4, 6, 8, right? And call it raw, comma 1. So basically, what this does is that hit the Modbus address 40,001. That will help, right? So the next one, assuming the next one is this 2, right? Another floating point. So you're gonna have to read number 2. I'm gonna go here, number 2. We're gonna call it. Let me create a tag. Underscore. Can I have comma underscore? And on here, call it a real. And this one, you want to call it, say, I don't know, 3691, something like that. 333, something, right? And call it a real as well. And then if you go back to your mapping, something like that, and this is going to be 40,003. That's how you read a floating point. Obviously, if okay, these two are float, and obviously if this is an integer, you just read one register and you're golden. Map it to an integer and you're good. Another thing I want to put focus on would be how you can actually read a discrete point. So for example, I know this is a discrete point here, 25. So you're gonna go here. Say I'm gonna call it 222. Say ys 4444. So I'm gonna define that tag here shortly. So you go here, dot 2, 20, 25, right? This is 25. And say I'm trying to read bit number, say 2, right? That's the bit that I'm reading. And then this one has to be a data type as Boolean. And that's how you map a digital tag. So this one would be Modbus address, say 1001. So 1, 2, 3. So it's going to be 10003. Anyway, so that's how you read a digital tag. So this will be oops. This will be digital. This will be real, right? And so on. And of course, don't forget to put the jump routine in here for you to map. So anyway, yeah, that's yeah. Once you make this change, verify it, make sure there's no issues with the program. I do have some issues because my main routine is blank here, and I would like to call a jump. Getting this guy here, GSR. Let's finish the program here. And then over here, you want to call, say, Prosoft routine for your add-on instruction. and then your mapping and everything. So ROU TINA calls, something like that. Let's try it, see if it works. It compiles well, no errors, all completed. Download the program, and you're laughing. Anyways, I hope this tutorial will help you. I know it became a bit too long, but it's a very detailed explanation. Please do check out my comment section as well. There's more details on a few other limitations of ranges of the internal register and whatnot. Other than that, have a great day. Bye now.